Hello friends, welcome to this video on application of Laplace for solving differential equation. This is a part 2 video. In part 1, we have defined the formulas for your first and second derivative of Laplace and we have applied the formula for derivative to solve the differential equation of second order. In this video, we will see some more problems on solving a differential using equations using Laplace technique. Come on, we will move on into the video. We have been solving differential equations of second order. This equation is being asked to solve for d square plus 1 times of y is 2e power t. We have been given y of 0 is 1 and y dash of 0 is 2. So, the first format which we saw, or in the first video which we saw, we had the equation written as y double dash plus y dash and a y. Now this has been given in the format d square plus 1 times of y. So this is nothing but my d square y plus 1 into y is my 2e power t. Now this can be written or replaced as, we can see that y is a function of t, hence this gives d square, that is my 2 times differentiation. D square represents d square by dt square operated on y. So d square y by dt square. So I can rewrite this as y double dash plus this is going to be my y with no derivative. So it is a simple y is 2e power t. Now I can rewrite this as y double dash of t plus y of t is 2e power t. How many orders are involved? It is a second order differential equation. So recollect the formula for the second order derivative, Laplace of y double dash of t and Laplace of y dash of t. So we will be using these formulas whenever required in our substitutions and derivations. Now the technique over here, step 1, you have to apply Laplace transform on both sides. Step 2, apply the conditions which has been given to us. Since it is estimated at t equal to 0, you call this to be initial conditions. So apply the initial conditions to the applied Laplace transform. Simplify them. Step 3, collecting the terms. Find the partial fraction of the given quantity. And in step 4, to remove the what is going to be effect of Laplace which we have applied in step 1, what we are going to do is apply inverse Laplace to our partial fractions answer. So this is going to be the step which we are going to follow. So we'll begin with step 1. What is our step 1? You apply Laplace transform on both sides of your differential equation. So this gives me Laplace of y double dash of t plus Laplace of y of t is Laplace of 2e power t. Now, what do we know about Laplace of y double dash of t? Substitute from over here. S square Laplace of y of t minus s y of 0 minus y dash of 0. So, this is my Laplace of second derivative. I have the second term as Laplace of y of t, which means I don't have a first order derivative. So ignore this formula. We may not requiring this formula for this problem. So directly write the second step as Laplace of y of t. What is on your right hand side? You have 2 times of Laplace of e power t, which is 1 divided by s. Since it is positive, it is going to be minus 1. So you have 2 into 1 divided by s minus 1. Now, what is my second step? My second step is to apply the initial conditions. What are going to be my initial conditions? My initial condition says y of 0 is 1 and y dash of 0 is 2. First we will see where is y of 0. Where is our y of 0? Here is our y of 0. Now what I'll have to do is, I'll have to replace this quantity y of 0 as 1. And what is the second condition? I have my y dash of 0 to be equal to 2. Where is my y dash of 0? Here is my y dash of 0, which I replace it as 2. So now I have s square Laplace of y of t minus s into 1 minus this quantity becomes 2 plus Laplace of y of t. So after that, what we do is we try to collect the Laplace of y of t. On collection, I have this as s square, and here the coefficient is 1. So s square plus 1. What are the left out terms? The left out terms are s into 1, which is minus s, and this y dash of 0 has been replaced as 2. So it is minus 2. And this is nothing but 2 divided by s minus 1. Keeping your Laplace and the coefficient to one side, I take the constants to the opposite side. So this gives me Laplace of y of t into, what was the coefficient? The coefficient was s square plus 1. The next term was minus s minus 2 will be taken to the opposite side. So this gives me 2 by s minus 1 minus 2 will now become plus 2, and the next term will be your what was it, minus s. So this will become plus s. So this has denominator as 1. So let me take s minus 1 as a common quantity as LCM. It is 2 plus s times of s minus 1. Let me take the LCM. So this gives me the quantity s minus 1, 2 plus 2s plus s square. The next term 2 into minus 1. So this is minus 2, and this is going to be minus s. On simplification, I have it as s square 2s minus s makes it as plus s plus 2. Minus 2 cancels off, leaving you with just s square plus s in the numerator and s minus 1 in the denominator. So I have Laplace of y of t to be equal to, you can cross multiply this to the opposite side, leaving you as Laplace of y of t to be s square plus s divided by s minus 1 s square plus 1. So this is my component. So I have completed till step 2. What is my step 3? My step 3 is computing partial fraction for it. So s square plus s by s minus 1 and s square plus 1. We notice this is going to be factorizable, but over here this cannot be factorized. Hence, the partial fraction will be of the format a by s minus 1 for the factorizable one, and this is non-factorizable. So I need two quantities because this is of power 2. So let me write it as bs plus c operated by s square plus 1 as the next fraction. Hence, I have it of the form a by s minus 1 plus bs plus c by s square plus 1. Now, since the denominators are going to be the same, I can take LCM, which is s minus 1, s square plus 1. So I will have a times of the left out quantity, which is s square plus 1, plus the next one is bs plus c. Operated at the left out term will be s minus 1. Compare the numerators over here for the first and the last term. Since the denominators are the same, I can equate the numerators. Hence, I have it as s square plus s to be a times of s square plus 1 plus bs plus c times of s minus 1. Now, I notice that I need three values to find the values of the constants a, b and c. How can I get them? I can get it from the factors. So for the first case, s minus 1 is a factor. So I have s minus 1, which I can equate it to 0. So I can substitute s as 1. When I put s to be equal to 1, I will have 1 plus 1. This contains s minus 1, which is equal to 0. 0 into something, this will vanish. and a will be evaluated as, I have substituted s as 1, so it is 1 plus 1. 2 is equal to a times of 2, 2 cancels off, leaving you with a as 1. The next thing which I will be requiring is going to be the second constant. So how to get the second constant over here? So let me equate one more value. So I have a s over here. Let me replace s to be 0. So when I put s equal to 0 on both sides, what will happen? This will become 0 plus 0, and now this contains s, so this becomes 0, which gives me a times of 0 plus 1, which is 1, plus this has gone because 0 into b, and so it is c times of 0 minus 1. I have 0 to be equal to a minus c. So my a is c, and I have already got the value of a, therefore c also turns out to be as 1. So the second quantity c is also obtained. Now how about the third quantity b? Now to estimate the third quantity b, let me compare coefficient of s square on both sides, because b has coefficient s into s, which is s square. So what is the coefficient of s square on your left hand side? This coefficient is going to be equal to 1. So 1 is equal to s square has coefficient over here as a. b is into s, so that is going to have coefficient as b. c has just coefficient s minus 1, so it doesn't have an s square coefficient. So from over here, I know a is 1, so my b is got as 0. So I have estimated the value for the constants a, b and c as 0, for b, a 1 and c 1. So now let us substitute these quantities in my partial fraction to get the answer back. Where I'll have to substitute, this has to be substituted over here in my step number 3. So a becomes equal to 1, s becomes 0 and c becomes equal to 1. Hence, I have s square plus s divided by s minus 1 into s square plus 1, which I had was a by s minus 1 plus bs plus c divided by s square plus 1. And now this gives me 1 divided by s minus 1, b into 0. So this term vanishes entirely, leaving you with just c. So you have c to be 1 divided by s square plus 1. So I have now completed the step 3. What is your step 4? I know that this is nothing but my Laplace of y of t. So I know that my Laplace of y of t is this. To get my y of t back, what is going to be my step 4? My step 4 is applying inverse Laplace transforms on both sides. So when I apply inverse Laplace transform, my Laplace and Laplace inverse vanishes, leaving you with y of t. But what happens on my right hand side? I will have Laplace inverse of 1 by s minus 1 plus Laplace inverse of 1 by s square plus 1. So this gives me y of t to be equal to, the first term is e to the power of positive t, and second term it is s square plus 1, a constant. So a constant means it is going to be sine, and the quantity over here for a is 1, so it is sine t. Hence y of t is e power t sine t. So students, just follow these 4 steps. What are they? We will recollect again. First apply Laplace, second apply the initial condition, form your partial fraction, apply inverse Laplace transform. So this will simplify the problem for you, and finally we will be able to arrive at the final solution y of t in a general manner. Thank you.